Hey there, this video is going to cover how to complete the radical review assignment, the one that's on Canvas and linked on ALEKS. If you have any additional questions, please reach out, let me know. We're going to go ahead and work our way through each problem. Feel free to jump around to whichever questions that you might have questions on. So question number 1 asks us to write a number that's a decimal as a fraction. And then it says, notice here, don't try to simplify your answer. So don't worry about simplifying your answer on this. We just want to get the basics of converting. So if I have the number 0.75 as a fraction, remember here's the rule. I make my fraction bar, I put the number that's after the decimal on top. Now here's one additional step that we started talking about this year. If my decimal is not repeating, if it terminates, that means I am going to count the number of digits. So there's 7 is the first digit, 5 is the second digit, and that tells me how many zeros to put in my denominator after a 1. So my answer is 75 over 100. It says not to simplify, so I'm going to leave it like this. Now on the other hand, if it asks me to write a repeating decimal as a fraction, I'm going to start the same way. I'm going to write that number on top of my fraction, but instead of writing 10, because 3 is only one digit, instead of a 1 and then a bunch of zeros, I'm going to have just some 9s. So because there's one digit, I'm going to place 1 9. If it asks me to simplify, I could simplify it to 1/3. So for example, let me give you just one other problem. If I had the problem 0.45 repeating, I would make a fraction. I'd put 45 on top, 45 on top, and in the denominator, because there's 2 digits after the decimal, I would put 2 9s, so 99, and that would be my answer. So as you are comparing non-repeating versus repeating, that denominator is going to change. So let's try one more with 0.0003 as a fraction. Is this repeating? The answer is no, so I'm going to put 1 and a bunch of zeros. Let's count how many zeros we need. We need 1, 2, 3, 4. There's 4 digits, so 1, 2, 3, 4. And what number am I going to put on? Now, I'm not going to put 0003. I'm just going to put that 3. And that is my final answer. Number 4 asks me to classify each as a rational or irrational number. Now remember, to tell the difference, rational has the word ratio on it, which means fraction. So in other words, rational number means I'm going to ask myself, can I write that number as a fraction? Irrational means it's not possible to write that number as a fraction. So let's go ahead and simplify. Let's see if we can write these as a fraction. So 69 and 0.13 repeating. Well, I can write 0.13 repeating as 13 over 99. 69 and 13 over 99, that can be written as a fraction, so it is rational. 81, can I write that as a fraction? Well, remember that we can test numbers by plugging them into the calculator. So square root of 81 is 9. Can I write, so that simplifies to 9. Can I write that as a fraction? I sure can. 9 over 1. That means that's a rational number. Radical of 26. Well, 5.09, now that continues on. It does not seem to terminate, and it does not do the same number pattern again and again or show that repeating sign. So, not a fraction. And because it's not a fraction, that means it's irrational. 3 over 18 is already written as a fraction, so it is definitely rational. And 20 pi. Now 20 times pi, you can test it in your calculator. 20 times pi, where's my pi button? Pi, there it is. You can see 62.831853, blah, blah, blah. That is not a fraction. I know it's not a fraction because it doesn't terminate like we did on example 1, and it doesn't repeat like example number 2. So not a fraction. Another way to know that it's not a fraction is anything with a pi is going to be irrational. Okay, question number 5 says, what is the value of the square root of 64? So remember, the square root is simply asking, hey, what number multiplied by itself is 64? So 8 times 8 gives me 64, so the square root of 64 equals 8, and that's just my final answer. On the other hand, number 6 is going to say something like this: find all the real square roots of 100. Now, I'm trying to think of two numbers that multiply together to give me 100. So that's 100, 10 and 10, and negative 10 and negative 10, because remember the negative and a negative is going to give me a positive. So my two answers are positive 10 and negative 10. Oftentimes I get the question of, why is the square root of 64 not also negative 8? Because when I have the square root sign, there's automatically a little plus sign out, imaginary plus sign out front. So my answer simplifies to positive 8. On the other hand, if I ask this question, I'm saying, what are the different possibilities of numbers that multiply to 100? And I have two. The second option says, find all real square roots of negative 64. Well, negative 64, I know that 8 times 8 is 64, but negative 8 times, and I know that negative 8 times 8 is negative 64, but since these aren't the same numbers, or even if I were to rearrange them, 8 and negative 8, these aren't the same, so there is none. There's no answer for the square root of negative 64. It's not possible. Question number 7 says, use the ALEKS calculator to approximate the square root of 37. So I'm going to use just any calculator. So the square root of 35. Square root of 35. And it says 5.9160. And I'm going to write 5.1960. And it continues. Now this is irrational, I can't write it as a fraction, but it just asked me to round to the nearest hundredth. 100 has 2 zeros in it, so I'm looking for 2 decimal places after. Now if you write your answer as 5.19, you're going to get the question wrong. Because remember, rounding also has to do with looking after that hundredths place and deciding if that 6 makes this 9 closer to 10. Well, yeah. 6 is above halfway to 10, so I'm going to round this number 9 up, which is going to, in turn, raise this 1 to a 2. So my answer is 5.20. Order these numbers from least to greatest. So on number 8, we are going to order them. Now, I find the easiest way to order numbers is to turn them all into the same format. And I like decimals because I think decimals are easier to compare. So I'm going to convert, this is a decimal 2. This is not a decimal, so let's type that in. So negative square root of 121 is negative 11. So negative 11 is what this is really saying. And 10 and 1/11. I'm just going to convert the 1/11, into a decimal, 0.090909. So I know the whole number, 0.0909, and it continues. So now that all of these numbers are in decimal form, I'm going to rank. Well, don't get tripped by the 11. Remember, negative numbers are the smallest. So negative 11 comes first. Now I'm comparing these 3 10 values, so I want to make sure I have the next smallest decimal. So 0.9 is smaller than 1.3. So 10 and 1/11. I'm going to go back and rewrite them in their original form. Then I have 10 point, well, what's next bigger? 13 is smaller, 1.3 is smaller than 2, and that repeating 2. So 1.3 and 10.2 repeating. So that is my order from least to greatest. Noticing I'm looking at that tenths place, that first decimal place after the decimal, and that's giving me enough information. Smaller, the next smallest, the next bigger, and the next bigger. All right, question 9 and 10 asked me to simplify radicals. Now remember, a square root of 25 would simplify to 5, but square root of 72 is not perfect. So I'm going to split it down so I can find some perfect squares. So 72 splits into 9 and 6, I believe. So we can test that out. 72 divided by 9 is 8. Oops. 9 splits into 3 and 3, and 8 splits into 4 and 2. Now I'm going to go back and cross out anything that I split so I don't use those numbers when I go to do my simplifying process. 4 splits into 2 and 2. So my new radical looks like this. 2 times 2 times 2 times 3 times 3. So how do I find my final answer? Remember, perfect squares are two numbers multiplied together, the same two numbers multiplied. So 2 times 2 and 3 times 3, these are my perfect squares, and they're going to come out front. The perfect square of 2 is going to come out front, and the perfect square of 3. This remaining 2 stays on the inside because it doesn't have a partner. So what does my final answer simplify? 2. On the outside, 2 times 3 is 6, and on the inside, I'm left with a remainder of 2. So 6 square roots of 2. Or your problem might look like this, square root of 20. So I'm going to factor 20. 20 splits into 2 and 10. 10 splits into 2 and 5. And nothing splits any further. So I'm going to rewrite my radical 2, 2, and 5. My perfect square comes from the 2 times 2. I'm going to pull a 2 out front and cross out the remaining thing on the inside. And so I end up with 2 radicals of 5 left over. Now, what do I do when the number is super large? I'm just going to simplify it as best I can. So 200 splits into 2 and 100. 100 splits into 10 and 10. Now, you could continue to simplify this, but notice that 100 is if it splits into 10 and 10, that's my perfect square. 10 times 10. So I'm going to rewrite this the shorthand way, and I'm not going to split that any further. So my perfect pair is 10 times 10. I'm going to pull out a 10 and leave a remainder of 2. So 10 square roots of 2. Now let's say you didn't notice that and you kept splitting 5 and 2, 5 and 2, and those can't be split anymore. 2, 2, 2, there's 3 2s and 2 5s. So pair of 2s and a pair of 5s that come out front that I multiply together to give me 10, and the remaining 2 on the inside. So you see I got the same answer either way, but I might save myself some steps by finding that perfect square up top. All right, 12 and 13 are going to look like this. So I've got the number and a variable. So remember, I simplify my radical the same way as any other. I'm going to factor 9 and 6. 9 splits into 3 and 3. 6 splits into 3 and 2. I'm going to rewrite my radical 3, 3, 3, and 2. So we've got 2 pairs. I've got 1 pair of 3s, and these lonely 2 and 3. So on the inside, I'm going to remultiply those. So I'm left with 3 radicals of 6. Now, if you write that as your final answer, we are forgetting about the v's. We got to go back for the v's. There's 13 of them. Now, I'm not going to take the time to write them all out, but I'm pairing them together. And that's how I know I can pull v's out front. So v times v means I'm going to pull 1 v out front. So if I have 13 v's, that means I'm going to have 6 pairs and 1 left over. So 6 pairs and 1 left over means I'm going to write 6 pairs of v's, so v to the power of 6. I'm going to write my radical sign. I'm going to rewrite the 6 that I had on the inside, and 1 remains on the inside. So my answer is 3 v to the 6th power square roots of 6v. Let's go ahead and talk about the second problem. So I'm going to simplify my radical. 3 times 9. 9 splits into 3 and 3. So I have 3, 3, and 3. Got one pair of 3's. So 3 comes out front, 1 3 remains on the inside, and I have 14 u's. So if I pair them all, 14 paired, so 14 divided by 2 is 7. So I have 7 pairs of u that go on the outside, and there's no remaining u's on the inside because it divided evenly. So that would be my final answer. All right. Now let's talk about not just simplifying, but let's talk about adding and subtracting. So if I wanted to simplify this radical expression, I am going to first check to make sure that the insides are the same. Remember, I can add together 2x and 6x because they have like terms. With radicals, they act like a variable. I can only combine them if they have like terms. And on this problem, they do. So same like term. So I'm just going to do the operation in front. 7 minus 2, which is 5 radicals of 10. So similarly, 14 and 14 are the same term. So I can combine 3 and 5 to give me 10. And I leave my radical the same. Notice I didn't combine the insides of those. On my last example, you'll notice that these radicals are not the same. So I can't combine them unless I can simplify them to be like. So let's see if I can do that. 75 splits into 5 and 15, I believe. Let's check that. 75 divided by 5. Whoops, I missed a 0 on that. 75 divided by, I did that again. 75 divided by 5 is 15. So sweet, I was right. And 15 splits into 5 and 3. So let's simplify this first radical. So negative 2 square roots of 5, 5, and 3. Circle a pair of 5s. Makes a perfect square. 5 on the outside combined with the negative 2 means negative 10 square roots of 3. Now you might say that's still not the same as a square root of 12, so simplify the square root of 12. See if I can. 12 simplifies to 4 and 3. 4 simplifies to 2 and 2. So yeah, the radical of 2, 2, and 3. I'm going to bring a pair of 2's out front. With nothing out front, I'm just going to bring down the positive 2 square roots of 3. Now you notice that they are the same. So my final answer is going to have square root of 3, and I'm going to combine the positive 2 and the negative 10, negative 8, and that's my final answer. So that is adding and subtracting. Let's talk multiplying radicals. So 16 and 17, 16 is going to look more like this one. 17 is going to look more like this one. So 16's going to be different. So I should say multiplying is different than adding and subtracting. I don't need these to be the same. Just like if I have 2 times 6x, I don't need this 2 and the 6 to be like terms. I can just multiply to give me 12x. Same thing with radicals. I can just multiply the numbers on the inside. So 6 times 2 is 12. And I do need to simplify that. 12 simplifies into 4 and 3. 4 simplifies into 2 and 2. When I rewrite them, I've got 2, 2, and 3 to bring into my radical sign. I circle my pair, I bring it out front, and I'm left with 2 radicals of 3 as my final answer. Now number 17 is going to look like one of these two problems. I'm going to multiply the outside numbers and the inside. So there's an imaginary 1 out front. 1 times 3 is 3. Now 54 times 75, that's going to be a really large number. 54 times 75. Instead of multiplying them together and getting a huge number that I have to then simplify, I'm going to just simplify them separately. Because all of that's still going to end up underneath my same square root. So 3 and then all of those numbers. So 54 simplifies to 9 and 6. 9 simplifies to 3 and 3. 6 simplifies to 3 and 2. Remember, I don't include any of those numbers. 75 simplified into 15 and 5. 15 simplified into 5 and 3. So I'm going to take all of my simplified terms and copy them all down in order. So I've got 2, 1, 2, 3, 4 threes. 1, 2, 3, 4. And I've got 5 and 2 5s. So circle your pairs, 2 3s, 2 more 3s, 2 5s, and I pull them out. So 3, 3, 5. So 3, 3, 5, and the 3 that's already there. So 3 times 3 times 5. 3 times 3 times 5 is, times the 3 that was already there, 135. Square roots of, what's the one thing that's left on the inside? 2. Similarly, I would do this problem right here. So multiply the outsides. 3 times 1 is 3. 12 and 48, I'm going to leave them separate. 12 simplifies to 4 and 3. 4 simplifies to 2 and 2. 48 simplifies to 6 and 8. 6 simplifies to 2 and 3. 4 and 2. 2 and 2. And we've got this big long thing. Remember, if I split it, I don't want to use it in my final answer. So we have 2, 2, 3. I'm going to skip the 3's for now. I'm just going to do 2, 2, 2, 2, 2. 2, 2, 2, 2. And then I have 1, 2, 3's. So circling pairs. Everything's a perfect pair. So pulling them all out. 3 times 2 times 2 times 2 times 3. The original 3 times 2 times 2 times 2 times 3 gives me 72. And that's my final answer. All right, so that was multiplying, and some of those can get a little bit lengthy, but remember just to break it down a little bit at a time. And if you have any questions, please reach out. Let's talk about simplifying these square roots. Now, sometimes this looks super overwhelming, and I can't really simplify either of these. Neither of them are perfect squares. Now, I'm going to take a shortcut on this problem. I want you to take that fraction. I'm actually going to go back to it so you can see it. And I'm going to rewrite it as one big radical, 75 over 3, pardon me. Now, if this doesn't divide, I'm going to have to separate it kind of like I did the multiplication, but maybe I'm lucky and 75 is divisible by 3. And wouldn't you know, 75 is divisible by 3. It's 25. So my answer simplifies to this. So I bring down 75 over 3, stays on the inside of the radical. And once I see the square root of 25, I say, hey, that's a perfect square. And I'm going to take the square root of that. 5 times 5 gives me 25, so my final answer is 5. On the second problem, I'm going to do something similar. 5 over 80 in the same radical. And I'm going to go into my calculator, and I'm going to say 5 over 80. And you might, 5 over 80. Now you might look at that and say it's a decimal, not so lucky, but click it back to a fraction. See how it says 1/16? If you ever have a decimal, turn it back into a fraction, because what I notice that even though it's a fraction, 16 is a perfect square. Square root of 16 is 4. You may not recognize it, but 1 is also a perfect square. The square root of 1 is 1. So I still have a fraction. 1 is still on top of 4, but I can simplify those separately. All right, last two problems. Find the value of the cubed root of 125. Remember, cubed roots mean I want to find what number multiplied by itself 3 times gives me 125. So we can do a factor tree, or we can just start dividing, or we can use our calculator. If you notice, this calculator has the ability to do a cubed root. If I had to click the one with the n, I can put a 3 there. 125, whoops, I typed that in wrong. 125, and I get 5. So that means 5 times 5 times 5 is 125. Let's look at this last one. So it says solve 343 square roots, of u cubed, where u is a real number. So I need to undo this cubed root by taking this radical of 3. And I want to know what number times itself 3 times is 343. So I can guess. I could be like 3 times 3 times 3. Nope, too small. Or I could say like 6 times 6 times 6. Oh, too small. And guess it. Or remember, you can take this cubed root of 343. That gives me 7. So my answer is u is equal to 7. And that is the review. If you have any questions, you need additional explanations, or you just need a little bit more help, please let me know. Reach out and we can schedule a Google Meet. Have a great day, and we'll talk to you later.